Hey, hi everyone, Shahid this side, and today in this session we are going to see what is Kubernetes. But before directly jump into the Kubernetes, orchestration tool, we have to understand the containerization. What is container? What is Docker container? Because there is no meaning of directly understand the orchestration tool, but you have to know what we have to manage, we have to orchestrate. Okay, so first of all, understand what is containerization, then we will move towards step by step what is orchestration tool for this. Come on. So what is the Docker container? See, the what first we understand the problem. What is the problem for using what why we required why we need the containerization. Let's explore some examples. Okay, so we have a developer writes a code, and the code which is in Python. Okay, it's Python, and it's write a genius code. He was like, I'm a genius, I'm a genius, I'm writing a code, perfect code. And it's runtime engine for Python is using, for example, 3.8 version, and it's all import all the dependencies and configuration. Then after, it's it's forward that whatever the code he writes the codes to the test environment. What happened? It's the test environment. The runtime engine is Python 3.6. The runtime engines it changes over here. So obviously, when runtime engine changes, the it's not able to import the kitchen sink or any dependencies over here. Then it's directly go towards the prod environment, production environment, and it's in prod. They are using version 2.7, and they can't and it's can't able to import any dependencies and configuration. Its database connection, its ports and services are not able to connect over there. So it's create a problem for the developer, and developer was like need to change the code and whatever the requirement for the according to runtime engine. But it's not possible, and it was like the developer was like, I write the right code and took all the dependencies and configuration. Why it's going to fail on fraud environment? It's because of its dependencies and configuration are not there in production. It's run on their machine, fine, okay, that's okay. But coming to the fraud environment, it's not working. And developers were like, developer, why I did take this job, huh? Tell me. It's a nice joke. You like it. Worked fine in dev, but ops problem now. Then after, it works on my machine. Okay, then we will ship your machine, and that is how Docker was born. Okay, what is container? Container. Let's understand the container word. It's the main concept. You have to learn because it's a logical concept. Some binaries, logical. Number of logical binaries are there. Okay, you have to understand what is the container. We will ship all the like your code, runtime, packages, library, dependencies in one box, wrapped into the one box. And that box is called container. Just remember this, it's that box is called container, right? So Docker, what is Docker image? We will create a whatever the code and dependency and configuration are wrapped into the one box, and build a image. Like in EC2 we will create a EC2 image, AMI image. That's what it's similarly, that is Docker image. That is called container image, and that is created a container. Understand? Let's let's move to the next big picture. Let's for example your app. Okay, or you like a Docker file, or you will create a Docker image or through Docker file. Docker file means what? There is a number of instructions over there. What is the image for that? What is the links out there? What is the port numbers are there? That is what the dependencies configuration, as we mentioned, that is a Docker file. Whatever the dependencies, whatever the configurations, whatever the code requirement, runtime environment is over there in Docker file. And we will create an image, like I discuss AMI, EC2 AMI, that's what EC Docker image, and we will push that image to any public repository, like you wherever you want, like Docker Hub, Elastic Container Registry, JCraft Archifactory, wherever you want. You have to put that repository, so that other people can access your repository if you want to deploy in public repository. Okay, then deploy, then after, whoever want to take that container, and whenever it's requirement, that other teams is requirement, other organization is requirement, they will push that pull that repository from that your local public hub, public repository. And that is what many Elastic Container Registry, K8s is coming. Okay, is it far clear over here? Because here you need to understand this. It's very important. Okay, let's understand the what is virtual machine and what is versus container. The difference between two. See, first of all, we see what is server, host, hypervisor. Both in both uh, diagram you can see in this frame. Everything is fine, but instead of hypervisor, we are using Docker. What is Docker? Docker, it's create a container and it's create a guest OS. For example, consider when you take create a AI EC2 image, EC2 instance. Okay, we have to select email that whatever is OS operating system, their volume, your size, VM size, whatever is that, and then we have to create that whatever your app inside it, and that will take most of the time your um, in this virtual machine. It will take like it will your boot up timing, your startup, it will take a lots of your memories, consume your consume your resources. But in this Docker, in this Docker side, it's just like it's very lightweight. It's very lightweight, and it's is binaries, libraries is in one container. Okay, so it's in MBs, and it will take a like seconds for or minutes for its booting up. So that's why this is the difference between them. Just instead of a hypervisor, we are using Docker. Okay, so advantages, you first of all you build that image. Okay, and that image can contain containers. Is it fine? And then after, the developer was like, I'm okay, I'm good. Now I can create any code and create an image for that code. So that is perfect for me, right? So has the Docker containerization. What is Docker? Docker creates your containers. Docker engine create your containers, right? Okay, guys. So as we discussed, like what is containerization, what is a Docker image, and we have to why we need Docker containerization. So for managing, for orchestrating the containerization, we are using Kubernetes. That is the most popular containerization orchestration tool. Okay, so that why we need Kubernetes. So first of all, that is a orchestrate that helps you to automate, deploy, scale, and manage your containerized application. If for example, if a container fails, Kubernetes will restart it, and if container isn't responding to your user defined or any Kubernetes can kill it that container and stop showing and recreate that containers. Okay, there are so many features like of it, self-healing, automatic rollouts and rollbacks, then after service discovery, load balancing for exposing your pods to the external service. Okay, then scaling of your application. Okay, then after resource monitoring, logging, you can monitor your resources or your pods through Kubernetes. Okay, through Kubernetes dashboards, and you can save the secrets configuration management. That means there was that authentication like SSH keys, oath tokens, without any rebuilding container images and exposing secrets in their stack configuration. Okay, so coming to the next slide, working backward, your application is created, then you will create a Docker image, and through Docker image you will run a container. So it's a Kubernetes architecture. First of all, we understand what is architecture of Kubernetes. It runs on master slave architecture. Master slave architecture. Okay, so we have master nodes, we have multiple slave nodes that runs on a container, that runs a containers inside it. That means there is a point of a pod here. Okay, we will understand it is the smallest atomic unit, and in it we running a container, whatever your container is there. Okay, so that is worker node. Okay, if your node gets failed, your master node detect that one of your node is failed, it will recreate another node. Okay, फर्स्ट वैसे मुझे कुछ बोलना है, अपने दिल की जो सुनी, एक राह यूं चुनी, और फिर निकल पड़े, हो के मस्त चल पड़े। मुश्किलें तो आएंगी, मुसीबतें डराएंगी, ज़िद पे तुम अड़े रहो, जज्बे से जुड़े रहो। हंसे कोई हंसा करे, मना करे, किया करें रुकावटों को तोड़ के, खौफ पीछे छोड़ के, जो आग से गुजर सको तो क्या है वो ना कर सको। सो कुछ करना है। Let's come to the point. Let's see the architecture. What is let's read me this. It's as I told you, it's work on your master slave architecture. In master we have like master control plane, then after your slave, this also called minions. Okay, this it's called nodes or minions. Okay, this is your master, this is your master plane, master control plane. This master control plane. Okay, as I told you, it's work on master slave architecture. So in master we have multiple components like API server, control manager, kube scheduler, then etcd, it's the key value store. Okay, first we understand like how it communicate with nodes and how it communicate with other in master side. Let's understand the terminology. What is API server? API server acts as a front end of the cluster, front end of the cluster. If other services, control manager, key scheduler, etc., wants to talk with the directly, don't talk with communicate with either, they communicate with each other. Okay, they first of all communicate with API server. Okay, and for nodes, obviously, if you want to talk, acts as a front end of the front end. Okay, if nodes also want to talk, that they don't directly talk with control manager, kube shadow. Do no, it's talk with it's communicate with API server. Got it? So API server is acts as a front end of the master. Okay, wherever you want to connect with that, you have to do like kubectl for connecting that. Then after your control manager is like your brain of your Kubernetes cluster. It's manage your desired state and current state. Okay, and its replication factor, deployments, replica sets, that it's managed by your control manager. Then after kube scheduler, what is kube scheduler? Kube scheduler is doing like it will do like scheduling the pods. What is pod? Just understand. I will show you. No problem. Okay, see what is a pod. In pod, understand this. In we have nodes, we have master slave architecture like we was discussed. Then after we are node in it, the slave node. In slave node there is a pod, there is a smallest unit. In pod there is a container. Okay, remember this. NPC, node pod container, node pod container. That's it, no problem. Okay, then after cube scheduler, we are discussing cube scheduler. What is cube scheduler? Cube scheduler was doing like arranging your pods on the nodes according to the resources requirement. What is the requirement of the resources for that pod? It's arranging the pods, but it's scheduled. It's not directly put your you know uh, pod into the node. It's scheduled like which pod goes on which node. It decide, okay, and it's tell to your API server. Every component in Kubernetes cluster in terms of master, in terms of nodes. Remember this. It's directly don't communicate with each other. They first directly communicate with API server. Okay, then we come to the etcd. Etcd is a key value. Okay, whatever the information it stores in like pods, nodes, or any other things. It's stored in a key value combination. Okay, coming to the nodes, minions. That means the minions, the nodes. It's a kubelet. It's acts as an agent. Okay, kubelet, it's acts as a agent and communication between Kubernetes master and the node, this node, for this node cluster. Okay, it ensures that container in pod is specified by Kubernetes manifest. It's talk with I have to delete this first of all because you guys get confused and you it's talk with API server. Let's move this kubelet. Okay, it's acts as an agent. Okay, it's talk with API server. Okay, everyone has kubelet. Then after CRI, container runtime engine. I'll explain each and everything. Don't worry. Then come to the kube proxy. Okay, then it's a that don't it's a it acts as an agent between nodes and master. Okay, it's not to directly communicate with API server, as I told you. Every component, that's why I'm highlighting this API server. Okay, then after come to the kube proxy. It will take the what then kubex maintains the network rules on nodes and enabling communication between pods and services. It set a it that means it sets a rule, stateful rules, or networking rules inside the nodes. Okay, that. And what is CRI? It's container runtime engine. Whatever you take, Docker, it's a runtime Docker engine. Then after your Rocket, these are the container runtime engine. Generally we are prefer Docker engine. I think everyone is sufficient for this time. Okay, then we have multiple components in it. Size service, in service we have nodes for connecting, you're exposing your ports to the external. Okay, then load balancer, the cluster IP. Okay, then ingress control. It's difficultly allowing traffic to reach the appropriate services based on defined rules, whatever rules it defines. Then we can see the dashboard. Okay, for Kubernetes provide a visual representation of the cluster. Okay, for administrator to perform various tasks. Okay, I think you guys understand whatever I am completing over here. And in next video we will come towards the practical session, how to deploy your EKS cluster. Okay, Elastic Kubernetes Services cluster. You don't worry about that. I will manage each and everything. So thank you everyone for watching this. Okay.